In this video, we're going to have a look at how to find the vector equation of a straight line. So let's start off with what we already know. Now we know the Cartesian equation of a straight line, and we know it's y equals mx plus c. And we know that the c, or the plus c, is the y-intercept, and that tells us where the line is. And we know that m is the gradient, and that's telling us how steep the line is. Now, what if we've got 3 dimensions? What if we've got an x, a y, and a z? How are we going to find the equation of a straight line in that situation? So let's have a look. Now let's say this point here is the origin, I'll call it O, and we want to get to a general point on this line, which I'll call R. So how are we going to get there? Now I know 2 things. I know that that line goes through this particular point A, and I know that the slope of the line is along the line of this vector B. So how do we get to R? Well, first of all, we go from O to the fixed point, and then we're going to walk along in steps, size B, until we get to the position R. So if I put those on there, so that's 3, and let's say we've got 3 3/5 vector B. So recapping, we're going to go from O to A, which I could call vector A, plus 1, 2, 3 3/5 of vector B. So we could write that as vector R, which is from O to R, is equal to vector A, which is O to A, plus 3.6 of vector B's. Now let's have a look at another one. So let's say this time we want a position on this line, which is the other side of vector A. So again, we can do the same thing. We go from O to A, which is a position on the line, and then we take backward steps of vector B, so 1, 2, to go to position R. So the vector from O to R, which is a position somewhere along the line, is OA plus 1, 2, or rather minus 1, 2 of vector B, because we're going backwards. So I've written it down here. So R equals A, vector A, plus minus 2 of vector B. So let's have a look at a general case here. So we've got an origin here. We know a fixed point on the line, and I could call that from O to A as little a. And then we know the direction of the line, and we want to get to a variable point R along that line. So we've got R equals fixed vector A plus, well, it's a variable number of vector B's, so let's call it lambda B, where lambda is a variable constant. And there's some similarities between our Cartesian equation and our vector equation. Now let's compare the two. So our fixed point on the Cartesian line is the plus c, and in the vector line it's our fixed point OA. So I'll link those two together. The other thing that we can compare is the slope or the gradient. Now in the Cartesian equation, the slope or the gradient of the line is m, and in the vector equation it's represented by vector b, so that tells us the direction of the line. The position we want to arrive at, in the Cartesian case it's y, and in the vector equation it's r. And then the variable bit, in the Cartesian equation it's our x that's the variable, and in the vector equation it's the lambda that's the variable. So they can match up there. Now let's have a look at an example. So find the equation of the line which passes through the point, say this point here, 2 minus 1, 7, and which is parallel to the vector 2i minus j, which could be represented by this red vector here. So we need two things. We need a position vector of a fixed point. Well, the only point that we know is this one here, 2 minus 1, 7. So written in vector form, it's 2 minus 1, 7 as a column vector. And I find it convenient to write it as a column vector. But equally, we could write it as 2i minus j plus 7k. And then we need a direction vector of the line, which is this one here. So I'm going to write this vector 2i minus j as column vector form. So 2 minus 1, 0. And not forgetting the k component is 0 there. So let's write down the equation of that line. So we've got position vector and a direction vector. This is our vector equation. So we're going to replace the a by our position vector. So r equals 2 minus 1, 7. And lambda times by the direction vector. So lambda multiplied by 2 minus 1, 0. And that's our equation of the straight line in vector form. Next example is find the equation of the line between two given points. So let's look at an example. Points A and B lie on the line. A and B have coordinates 2, 4, minus 1 and 3, 1, 1 respectively, and find the equation of the line. Or rather, find an equation of the line. So one thing to point out, with the vector equation, there's an infinite number of possible solutions because the fixed point A can be any point along the line. So let's draw a diagram here. It's always useful to see what's going on. So we've got an origin. I've just drawn the line anywhere on the page, and I've put two points on there to represent A and B. And when we're in 3 dimensions, it doesn't actually matter where we put A and B. And then I've just done a red vector here just to show the direction of that line. Now, what is the direction of that line? Now, one way of finding a particular vector for the red one to represent the direction is the vector that goes from point A to B. Now, how do we find vector AB? Well, first of all, we go from A to O, followed by O to B. So that's AO plus OB. And just changing that around, because we know that AO is equal to minus OA. So that could be written now as OB minus OA. Or we could do little b minus little a. So that's our direction vector. Now just putting in the actual vectors, so AB is OB minus OA. Well, OB as a vector is 3, 1, 1, minus OA as a vector, which is 2, 4, minus 1. Well, subtracting those, we get 1, minus 3, and 2. So there's our direction vector for the line. So we've now got everything we need. We need a fixed point and we need a direction vector. So just writing down our equation of the straight line, we've just said that AB is our direction vector. So I'll put that one in first. So it's lambda 1 minus 3, 2. And a position vector, well, we've got two here to choose from. Both of them would be equally okay, so I'll just take the first one. And we've got one possible solution now for our equation of the line is r equals 2, 4, minus 1, minus lambda 1, minus 3, 2. Now it's your turn. So for homework, what I would like you to do is find the vector equation of the line, and we'll call it L1, which passes through the points 1, -2, 3 and -1, 4, 4. And I'd also like you to have a think about this question. And the question is, does the point 3, 1, 1 or 3, 3, 1 lie on the line L1 in question 1? I'd like you to do that for homework and hand it in next lesson.